Good day everyone! This is your statistics and probability class. We are now going to discuss about constructing probability distributions. For our learning competency, the students will be able to illustrate a probability distribution for a discrete random variable and its properties. Probability. It is the extent to which an event is likely to occur, measured by the ratio of the favorable cases to the whole number of cases possible. Constructing probability distributions. Here is an entry card. On the left column is the event, and we are going to find the probability of each event. Number 1. Getting an even number in a single roll of a die. So notice a die. These are the faces of a die. So there are 6 faces. So we are going to find the even numbers only. So the even numbers are 2, 4, and 6. So there are 3 possibilities. So that would be 3 over 6 or 1/2. Number 2. Getting an ace when a card is drawn from a deck. So a deck of cards are 52 cards. So the aces there are 4. So there are 4 aces. So that would be 4 over 52 or 1 over 13. Number 3. The probability that all children are boys if a couple has 3 children. So number of cases. So the first child, it's maybe a girl or a boy. So that would be 2 multiplied by second child has probability of maybe girl or boy. So another 2 times the third child. So either girl or boy. So 2. So that would be 8. So the outcomes are BBB, BBG, BGB, GBB, GGB, GBG, BGG, and GGG. So in here, we are going to find the probability that all children are boys. So here it is. So BBB. So that would be 1 out of 8. Getting a red queen when a card is drawn from a deck. So there are 52 cards again from a deck. So we are going to find the red queen. The only red queen is coming from hearts and diamonds. So that would be 2 out of 52 or 1 over 26. Last, number 5. Getting a red ball from a box containing 3 red and 6 black balls. So how many balls are there? That would be 9. So here it is. So there are 3 red and 6 black balls. So 3 out of 9 or 1 over 3. So here are the answers on the entry card. So that would be number 1, getting an even number from a single roll of a die. So the probability is 3 over 6 or 1/2. Number 2, getting an ace when a card is drawn from a deck.
4 over 52
or 1 over 13. Number 3, the probability that all children are boys if a couple has 3 children. So 1 over 8. Number 4, getting a red queen when a card is drawn from a deck. So that would be 2 over 52 or 1 over 26. Number 5, getting a red ball from a box containing 3 red and 6 black balls. So that would be 3 over 9 or 1 over 3. Decision making. It is an important aspect in business, education, insurance, and other real-life situations. Many decisions are made by assigning the probabilities to all possible outcomes pertaining to the situation and then evaluating the results. Number of tails. Suppose 3 coins are tossed. Let y be the random variable representing the number of tails that occur. Possible outcomes, so that would be t, t, t. The value of the random variable, or y, or the number of tails, is 3. t, th, so that would be 2. tht, 2. thh, 1. hht, 1. hth, 1. htt, 2. and hhh, or 0. So in this table, the number of tails on the left column, on the right column is the probability. So 0 number of tails, so that would be 1 out of 8. 1 number of tails, so 3 over 8. Number 2, or 2 number of tails, so that would be 3 over 8. And for 3 tails, so that would be 1 over 8. So this table is known as the probability distribution, or the probability mass function of discrete random variable y. This can also be written like this. Number of tails y, 0. So the probability is 1 over 8. 1, 3 over 8, 2, 3 over 8, and 3, 1 over 8. Discrete probability distribution, also known as probability mass function, consists of the values a random variable can assume and the corresponding probabilities of the values. Number of blue balls. 2 balls are drawn in succession without replacement from an urn containing 5 red balls and 6 blue balls. Let z be the random variable representing the number of blue balls. Construct the probability distribution of the random variable z. So here are the possible outcomes. RR. So the value of the random variable z, or the number of blue balls, 0. Next, RB. So that would be 1. BR, 1. And BB, 2. So here is the table. On the left side, or the left column, the number of blue balls. In the right column, probability PZ. So in 0 blue balls, the probability is 1 over 4. 1, so the probability is 1 over 2. And 2, that is 1 over 4. That is the probability distribution, or probability mass function of discrete random variable z. It can also be written like this. Number of blue balls, 0. So the probability is 1 over 4. 1, so 1/2, and 2, 1 over 4. How to make histogram for the probability distribution. Number 1. Plot the values of the random variable along the horizontal axis. Number 2. Plot the probabilities along the vertical axis. So here is an example below. Another example. In the experiment of tossing a coin twice, there are 4 possible outcomes. H for the head and T for the tail. So H, H, T, th, and tt. If x is a random variable representing the number of tails in the outcomes, then x is equal to 0, 1, and 2. From the outcomes, HH means 0 tail, HT means 1 tail, TH means 1 tail, and TT means 2 tails. So, the probability that 0 tails will come out is 1/4. The probability that 1 tail will come out is 1/2. That is because there are 2/4. So that would result to 1/2. The probability that 2 tails will come out is 1/4. So below is the probability distribution. And here is the histogram for the probability distribution of the discrete random variable x. Number of defective laptops. Suppose 3 laptops are tested at random. Let D represent the defective laptop and N represent the non-defective laptop. Let X be the random variable for the number of defective laptops. On the first column are the possible outcomes. On the second column is the value of the random variable X for the number of defective laptops. DDD 3, DDN 2, DND 2, DNN 1, NDD 2, NDN 1, NND 1, NNN 0. So the values of the random variable x are 0, 1, 2, and 3. And here is the probability distribution. And below is the histogram. What have you noticed about the probability of each value of the random variable? What have you noticed about the sum of the probabilities of all values of the random variable? Notice the sum of the probabilities. 1/8 plus 3/8 plus 3/8 plus 1/8. That would be 8/8, or that would be 1. The properties of a probability distribution. The probability of each value of the random variable must be between or equal to 0 and 1. In symbol, we write it as 0 is less than equal to p of x, or less than or equal to 1. The sum of the probabilities of all values of the random variable must be equal to 1. In symbol, we write it as the sum of the probability, which is equal to 1, or summation of p of x is equal to 1. Let's now have an assessment. Determine whether the distribution represents a probability distribution. You have 1 minute to solve this. Number 1, no. Number 2, yes. Number 3, no. Now here are the photo references. And here is the reference from Rene R. Belicina, Elisa S. Bakay, and Efren B. Mateo of Statistics and Probability from Rex Bookstore. Thank you very much for watching and listening. Subscribe for more content.